YouTube, my name is Ms. V and you've made it to my channel, Ms. V's Mathies, which means that you are looking for some help in your math class and I am here to help you. So today what we're going to be talking about is reflections in geometry. So if you like this video, go ahead and click that subscribe button and hit the like button so that I know to keep making more content on geometry and I know what you guys are looking for. So let's go ahead and jump right into it. And if you see me looking down, it's because I'm writing. Okay, so let's go ahead and get started. So like I said, today we are going to be talking about reflections. Okay. And reflections in geometry are a type of rigid motion. If you don't know exactly what a rigid motion is, go ahead and take a look at my other video, rigid motion versus non-rigid motion, so you can get a clearer understanding of the difference between the two. So reflections are a type of rigid motion, and specifically we call reflections a flip, okay? So what you're used to seeing in previous math courses before geometry, like let's say middle school math courses, they talk about reflections, but instead of calling it that, they'll call it a flip, okay? So the idea of a reflection, and let me pick a pre-image where you can clearly tell that it's been flipped. Let's say we have something like this. So kind of like a trapezoid, I guess you could say. Actually, let's just do a trapezoid. So let's say we have a trapezoid. Okay. And I decide that I want to flip that trapezoid. Let's say that it is on the, let's say this is my coordinate grid right here. And I want to flip that trapezoid over the y-axis. Okay, so I'm going to grab that trapezoid and flip it over the y-axis. So this in green is my pre-image, which is what your transformation is before you do anything at all to it. So when you first get your paper or your question, the image before you do any transformation to it, that is called the pre-image. And let's say I say, okay, let's reflect this, reflect trapezoid about y-axis. So about the y-axis, that just means flip it over the y-axis. So an easy way to tell where the trapezoid should be if you flip it over a specific axis is to count how far away from that axis each point is. So for example, let's say this point over here is point A. Point A is 2 spaces away from the y-axis towards the left. So once I flip it about the y-axis, it's still going to be 2 spaces away, but it's going to be on the opposite side. So now that's going to be A prime, or your first image A. Then here is B, and B is about 1, 2, 3, 4, 5 units to the left away from the y-axis. So now I'm going to go ahead and count 5 units to the right from the y-axis. So 1, 2, 3, 4, 5 units. So B prime, or the image of B, should be right over here. Okay? And then you do the same thing with C and with D. So C is 3 points away towards the left. So now we're going to go 3 points away towards the right. So here's C, and D is just 1 more away than C is, so it's over here. So now that trapezoid has been reflected about the y-axis or over the y-axis, okay? There are different ways that you can reflect your figure. You can reflect it over the y-axis, you can reflect it over the x-axis, so you can reflect it over the line y equals x. So we have the y-axis, the x-axis, y equals x, the origin. These are some basic points or lines that are usually chosen when we're doing reflections. But again, you can reflect over any line whatsoever. So if I wanted to, I can even reflect over the line y equals -2, or I can reflect over the line x equals 4, okay? So if you have that kind of reflection, one thing I would suggest is draw the line out, because it makes it so much easier to actually figure out where your image should be after you do that reflection. okay? So that's just the basic overview of what reflections are. Now let's go ahead and jump into this example here. So we're going to reflect this triangle LMN about the following lines. So I picked the y-axis, I picked the x-axis, and I picked the line y equals x as some of the basic ones. And I'm going to go ahead and label each of these using colors. So my y-axis is going to be in purple. And we know the y-axis goes vertically up and down. And if you don't know that, then you can go ahead and watch my video on translations. I talk a little bit more about that as well. And then the x-axis is going to be in green, which goes horizontally. And finally, the line y equals x, I'll do it in pink. So the line y equals x. So when you're graphing this line, think about slope-intercept form, okay? And I don't want to get too into it because we're talking about reflections today. But in another video, when I start covering algebra topics, I'll go ahead and I'll talk about slope-intercept form and how to figure out how to graph a line. But the line y equals x, just think about y and x being the same thing at each point. So for example, right here, x is 1, y is also 1. At the origin, x is 0, y is also 0. Over here, x is -1, y is also -1. So that line y equals x is just you saying, oh, this is where y and x are the same exact thing, okay? And I'm going to try and draw this line as straight as possible, y'all. Don't make fun of me. And I also don't want to cut through that letter L, okay? So that pink line is y equals x, okay? Now, the easiest way to do this is to use reflection rules, okay? So we're gonna go ahead and talk about some of the reflection rules. So some of my reflection rules are, let's say if I wanna reflect about the x, let's do the y-axis first. So let's say I'm reflecting about the y-axis, okay? You have a function rule for whenever you do some kind of transformation. I talked about function rules more in depth in my last video on translations. So I'm just going to go ahead and tell you guys what the function rule is for when you reflect about the y-axis, okay? So whenever you reflect about the y-axis, your function rule, think of it as do the opposite of x and leave y the same, okay? It's kind of like what I did up here in this example. My x value here was -2. The opposite of -2 is +2, but notice how y stayed the same, okay? So when you reflect about the y-axis, change the sign of x and leave y the same. So the opposite of that would be true for when we reflect about the x-axis, okay? So in the case of reflecting about the x-axis, now I'm going to leave x the same and do the opposite of y, okay? And last but not least, if you reflect about the line y equals x, all you have to do is switch x and y, okay? So your new point, you start off at x comma y. When you reflected about the line y equals x, just switch x and y. Pretty simple to remember, okay? So I have the picture there for that figure LMN, and you can visually see what's going to happen when you reflected about these different axes. But I kind of like using the function rules a little bit more because I think it's a little easier to understand than actually going through and trying to figure out where each point should be on the figure. Now, obviously, you can still use the same method I used before where I counted how far away it was from each of those lines. But that becomes a little bit more tricky when you're doing something like reflecting about the line y equals x, because it's a straight line, but it's not straight vertically or horizontally. It's kind of diagonal, okay? So when we reflect about the y-axis, let's say I have point L, which is at 2, 2. So I'm going to do my reflect about the y-axis first, okay? Reflect about the y-axis. So L is at 2, 2. If I follow that function rule, which says that x comma y becomes -x comma y, all I'm doing is I'm changing L, the value of x for L is 2, and y is also 2. But remember, we're not changing y. So now my new point, L prime, or the image, change the sign of x, leave y the same. Okay? Same thing for M. M is at 0, -2. Again, change the sign of x. In this case, it's 0, so it doesn't change. You can't have -0. So M didn't move. And finally, we have N, which is at -1, 3. So again, we're reflecting about the y-axis, so just change the sign. I forgot to add that. Change the sign of x, which is -1. So if I change the sign, it'll be +1. And leave y the same, okay? So that is when you reflect about the y-axis. If I reflect about the x-axis, it's the same idea. The only difference is instead of changing the sign of x, now you're going to be changing the sign of y. So now x stays the same and you change the sign of y, okay? L is at 2, 2, which means that the image of L, so the pre-image is at 2, 2, the image is going to be at 2, -2. All I did was change the sign of y. M is at 0, -2. So now if I reflect it about the x-axis, it'll be at 0, +2. And N is at -1, 3. Again, if I reflect it about the x-axis, leave x the same, change the sign of y. So those would be your new points when you reflect about the x-axis, okay? So if you want to go ahead and practice this, I would pause the video here and you try to reflect it about the line y = x. So go ahead and try to reflect about y = x using the function rule that I gave you. And once you're ready, just go ahead and click play and check your answers with me so you can see how you did. All right, so our first point, L is at 2, 2. If I reflected about the y-axis, I'm switching x and y. In this case, x and y are the same for that point. So it stays at 2, 2. M is at 0, -2. I'm going to go ahead and switch x and y. So now M would be at -2, 0. And finally, N is at -1, 3. If I switch x and y, I'm going to be at 3, -1. Okay. So those are some of your basic reflection rules. So I gave you the reflection rules for the x-axis, the y-axis, and the line y = x. When you start to reflect about different lines like y = 2 or x = -3, that's when these rules are a little bit different because now you're not on the x or the y, on the x or the y axis specifically. Now you kind of shifted your line. So in that case, it would be helpful to do the first method that I did up here, which is where I counted how far away that point was from that specific line, okay? So I hope you enjoyed this video. If you did, go ahead and consider subscribing to my channel. Don't consider it, just do it because you know you're going to keep watching math videos and you're going to not know where to go. So go ahead and subscribe to my channel, like this video so that I know to keep making content on geometry, and I will see you guys in my next video. Bye.